Hey everybody, this is Larry. This is day 29, I think, or whatever day it is, of the Leetcode Day Challenge. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about today's pod. Right now, I am trying some delicious cold beet soup. It's pink, but it tastes good. It's just pink, I don't know. I just want to let you know. Yeah, it's the local favorite apparently, so yeah, good. Let's go. Hey everybody, this is Larry. This is day, I think 29, I don't know what it is, of the Leetcode Day Challenge. Maybe it's 30. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. Here today I am with this cute cat, with its cute tail. I don't know, I'm stroking it like that. Alright, let's get to the farm. Hey everybody. Yeah, I'm still here in wilderness. It is actually 4 a.m. here for me. I just kind of woke up from sleeping. So I'm still in bed. There's no light anywhere, so this is gonna be as good as you get. Yeah. Hope you enjoyed the intro. I did 2 of them because I didn't know which one to choose. I know it's weird, but I was just walking around the city today, mostly talking about the city and stuff like that. So yeah. Let me know what you think. My eyes are still like, I don't know. I'm really tired, and I don't want to do anything, but I can, like, go back to sleep. So so this is what I'm doing. Yeah. Let's take a look at today's problem. We have 2962. Count subarrays where max element appears at least k times. You're given an integer array nums and a positive integer k. Return the number of subarrays where the maximum element of nums appears at least k times in a subarray. Subarray is a contiguous sequence of elements in an array. Okay. So I mean, I think this is kind of what we were talking about in yesterday's video, right? It is sliding window, but I think the idea here is that why is it sliding window, right? And I do want to give a couple of minutes to do it, to talk about it. I do have to catch a bus at some point, so I mean, I don't think I'm gonna take like 2 hours anyway, but I should pack a little bit. So I'm not. But the idea here is that, okay, right? The first thing is contribution, right? We talked about contribution on, I think, yesterday and the day before. But the idea behind contribution is that, okay, you're given an array, right? Or sorry, you're given this array, and then you have one element, and you do this for every element, right? You're given this element. This is the last element in your subarray. How many times does it satisfy? What is its contribution to the final answer, right? Hence, that's why I call it the contribution method. So then here for 3, what is this contribution, right? What is it? K is 0 to 2. Maximum number of elements at least k times. So then you can't do the thing, right? And in this one, there are things you can do because you define kind of the, okay, so this is the last element. I just for notation's sake, go to the right side, right? And then now there's the left side of this, say, and there needs to be condition, whatever it is, that and you have to define it, right? That helps you count the number of things, right? Here, maybe the case would be that the condition is that between these left-right bounds, you try to find the point in which, in this case, maybe less than k times, right? Because if L is less than k times, then that means that everything, the first place in which it is less than k times, because then that means that everything to the left of L is a valid array, and then just kind of do the math from, just counting the number of things, and from that, right? Yeah, and from that, yeah, now you have this condition, and you could probably have binary search for it like I did yesterday, but today you can also think about it in terms of sliding window, right? And why does sliding window work on stuff like this? Well, it is almost like a previous, because I think for this problem you can also binary search if you're a little bit clever and all these things, right? Because the thing is that there is the same property in which if you extend away more and more, this can only be more true, right? Like there's no, it becomes true and then it becomes false and then it becomes true. You know, there's no like this up and down kind of thing. It's going to be false, 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 true, right? So you can binary search again, like I did yesterday, even though that isn't optimal. But the idea behind this problem or sliding window in general is that, and when you fix the right side, when you move the right side, sorry, by one only, then here the left side, well, this is the previous left side, right? And then how do you update it? Well, you know that going to the left, they're already good, right? So they were good. They were good when we were at this location. That means that when we moved the R to the right, it will also be good, right? Everything to the left is still good. And by good, I mean like it satisfied this condition, right? So then, but did this change, right? This is the only place that it could have changed because everything to the left is good. Well, this is the only thing that could change so far. So then you have to move it to the left, or you have to check it. And if the condition changed, then I can't. Yeah, if the condition changed, then you move it to the left, right? Sorry, move it to the right. Yes, I need your drawing board, but I'm traveling, sorry, friends. And then this could change as well, right? Because this is new, so then this is at the new frontier, and so forth. And that's how you kind of get this intuition around sliding windows, right? So without further ado, we can do it this way, right? So so I'm doing it from bed. Also, I hurt my finger. I don't know how. So like my index finger, my pointer finger. I'm looking like I'm saying no or something, but it's just like my fingers point. So my typing is a little bit awkward right now. It is what it is, right? But yeah, and then we want to keep track of the frequency of the counter, right? Yeah. Oh, I misread this one. I was like, this is kind of hard actually. Maybe I messed up because I have to kind of, like, it'll be n squared, we do a frequency of the table and stuff like that. And I just misread it and I misunderstood it. In that it was the maximum element of the subarray and not the maximum element of the entire array. That's a different problem. That's kind of hard. I mean, it's still doable. There are data. I mean, you can write a data structure in which you maintain the maximum of a you have to write your own kind of thing. And maybe as an upsolve, you can try to do it. Because you can do this with maintaining like a linked list of all the numbers based on all. And it is definitely a problem in Leetcode, so you could do it. But this is actually the maximum element of num, so you don't even have to. Yeah, so this is actually much easier. But I've also misread it. So yeah, so max element maybe max is equal to max of nums, right? So then now you would just have a count, and that's all we have to do, just keep count, right? Here, if num sub right is equal to max element, count, and then now while count, while count is greater than equal to k, then we want to increment by left, but oops, but only so we want to move the left pointer. Right, and that's basically it. And then now, so the left pointer is the first pointer in which this thing is not true. So everything to the right of it is true, right? So if the pointer is at 0, then you have 0 good arrays, and if the left pointer is at 1, you have 0 is the index that you can choose on the left side. So you have 1, right? So then you could just do something like this, and I think, oops, someone like it, mostly the correct way of doing it, right? And that's pretty much it. My typing is off, and yeah, that's pretty much it. Yeah, let me know what you think. This is linear time, constant space, and this is why I didn't talk about complexity, because I knew this was linear time, right? And that's why I was thinking about complexity when I thought it was, when I misread it as max element of the subarray. Then the complexity does matter, right? More here, you know, you look at this and it's linear time, linear space. or sorry, linear time constant space actually, even, right? And that's why I didn't talk about complexity, but that's because I knew it was linear, right? Because the right pointer can only increment n times, obviously, but here the left pointer can also only increment n times, right? Because left can only go from 0 to n once, right? So that's linear time. And yeah, I'm gonna call it a night. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about Larry and this trip. I'll see y'all later and take care. Bye bye.